Let's discuss air conditioning loads and panel schedules and clarify the proper method for calculating branch circuit loads. Your office policy of using the sum of the compressor's running load amps and the fan's full load amps for the breaker's load in a panel schedule for a condensing unit, with an additional 25% of the largest motor added to the column totals as a separate entry, is not entirely correct based on the National Electrical Code, specifically Section 220.14. While it's true that 220.14 is primarily focused on feeder calculations, it does apply to branch circuits supplying motor loads, including air conditioning condensing units. The definition of a feeder, as outlined in Article 100, encompasses any conductor extending from the service equipment to the final branch circuit of a current protective device. Therefore, the requirements of 220.14 can indeed impact branch circuit calculations. The critical element here is the concept of the minimum circuit ampacity, abbreviated as MCA. Section 220.14, paragraph A, mandates that all loads be considered continuous unless their demand characteristics allow for a lower calculated load. Motors, particularly those in air conditioning systems, are generally considered continuous loads. This means the minimum circuit ampacity, abbreviated MCA, must be utilized in the panel schedule load calculations. It's imperative to understand that the sum of the compressor's running load amps, abbreviated RLA, and the fan's full load amps, abbreviated FLA, might be less than the minimum circuit ampacity, especially with larger motors. Using the combined RLA and FLA could potentially result in an undersized circuit, which violates code and poses safety risks. Now, regarding 220.3, paragraph B, which permits the use of demand factors in calculating conductor ampacity, this does not override the specific requirement in 220.14 mandating the use of the minimum circuit ampacity for motor loads. Therefore, the appropriate load to enter in the panel schedule for a branch circuit serving a condensing unit is the minimum circuit ampacity. Your office's previous policy of simply adding the RLA and FLA is not in full compliance with the NEC requirements. In summary, code requirements for motor loads dictate the use of the minimum circuit ampacity, not just the sum of running load amps and full load amps. This ensures that the circuit is adequately sized for the motor's operational demands.